Hi everybody. Today we are continuing to interpret data in graphs, and we are going to look at broken line graphs and scatter plots today. Scatter plots are relatively new for grade 6s, so I'll spend a little bit more time on that, but I will review broken line graphs first. All right, so to start off with, we're going to look at a broken line graph. So similar to bar graphs, they're all going to have a title at the top. And this one, we are looking at the average highest temperatures in Jamaica over a year. You can see across the x-axis at the bottom, we have all of the months from January to December. So there would be 12 pieces of data here. On the y-axis, you can see that we have the temperature, and the temperature intervals are just going up by 1 degree. And this one's a little bit different because it starts at 27 degrees. It's decided that since no data is less than 29, it doesn't make sense to start all the way down at 0 and just have a whole bunch of blank marks between 0 and 29. So they've started at 27 here for their temperature on their y-axis. So that's a little bit different and interesting. Now you can see for each of the months, you'll see a dot or a little square on here to show the exact temperature. So you can see in January, the dot is at 30, and in February, the dot's down at 29. In March, it went back up to 30. Now the reason they're connected with lines is because it's because we can make the relationship more obvious by looking at the line. We can see the decreases and the increases based on which way the slope of the line is. So we can see at first it goes down, but then for the next 1, 2, 3, it increases. It then stays the same for a couple of months. It increases as the slope goes up, it decreases, stays the same. So like we said, it really shows a relationship over time very well by being able to follow that slope of the line. Now, for this one, we would be able to then look at what is the range in the temperature in Jamaica over the year. So the range is always the smallest to the largest, or the largest to the smallest. What's the difference between those two numbers? So we can see the largest number, the highest number it reaches is an average of 33 degrees Celsius, and we're going to subtract the coldest month, which is just 29 degrees Celsius. And we can see that the range in temperature only differs by 4 degrees. So you can see in Jamaica, it would be much different than here in Canada, where our temperature averages might range closer to from 25 to -10. So much greater one. Very consistent weather in Jamaica. So I'm just going to move that down over here for my answer. And then let's have a look at the second one. It says, what was the overall average temperature in Jamaica? So each of these are the monthly averages. What was the overall average? Now, when we look at average, we're typically, if it says average, it's asking for mean. So to find the mean, we are going to add up all the numbers that you see in the graph here. So we are going to add 30 plus 29 plus 30 plus 31 plus 32, and it stays there for a couple more, so plus 32 plus 32. So there's 3 32s in a row, plus 33 plus back to 32, plus stayed at 32 again, plus down to 31, and then stays at 31. So 31 plus 31. And a quick count here, there should be 12 numbers in my set of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So lots of things you can play with here. You could find the mean, the median, or the mode. So I can look through these numbers and I noticed how many 32s there were. So I'm assuming that 32 is going to be the mode here, as there's 1, 2, 3, 4, 5 32s. No more have that. So you could type the mode as being 32. We could find the middle number in this range. So I could rearrange these in order from smallest to greatest. And if I did that, I'm still going to find that the median is also 32. but the mean is the one that we typically use for average. So when we do this to find the mean, we are going to add those up and come up with a total. So I'm going to go ahead and put those in on my calculator in my hand here. So 30 plus 29 plus 30 plus 31 plus 32 plus 32 plus 32 plus 33 plus 32 plus 32 plus 31 plus 31 equals, and I'm going to get 375. Now, after I've done that, I need to divide it by how many pieces of data are in my data set, which is 12, one for each month. So divide that by 12, and I'm going to get an average temperature of 31.25. So over the course of the year, and it would be this 29 that drops it down quite a bit, the average temperature would be 31.25. Okay, let's move on to scatter plots now. You can see that I've put in two different scatter plots as examples here. Let's talk about a scatter plot for a second. I'm going to just zoom in on it for you to see it a little bit bigger here. Now, what a scatter plot is, a scatter plot is two different pieces of data plotted together. We're trying to find out if there's a relationship between those two different pieces of data. So what I have here for you is the age of students, whether they're 11, 12, 13, or 14, compared to the shoe size of those students, whether they're a size anywhere from 6 to a 9. Now, what I'm looking for is any sort of relationship in this data. Is there a relationship between shoe size and the age of 11 to 14-year-olds? Now, you can see here that there's all sorts of different plots. They're all overspread pretty evenly around the graph. There's 11-year-olds with size 6, but there's also 11-year-olds with size 9. There are 14-year-olds with 6.5s and with 9. So you can see that on this scatter plot, you cannot find a relationship between the age of the students and the size of their shoes. It's not going to help us. Their age is not going to help us predict their shoe size, nor would their shoe size help us predict how old they are. Those two things are unrelated when we plot them on a scatter plot. How many pieces of data do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So these are 14 different students plotted here. Student 1 is 11 with a size 6 shoe. Student 2 is 11 with a 6.5 shoe. And I could go on from there. Okay? So if I look down at this question, is there a positive trend? Is there a negative trend? Is there a constant trend, or is there no trend? There is no trend. This data would not help us make any sort of predictions. Let's compare that to the scatter plot that's over here. So for the scatter plot over here, again, you can see the two different things that we are going to look at this time. This time we're going to compare somebody's height to the length of their feet. Could we make some sort of conclusion that a taller person is going to have longer feet, bigger feet? And you can see how the data spread on this is much different. There seems to be an upward trend here. Let's just have a look at some of the data. You can see that they have a key where the circles with the dot in the middle represents a boy's foot, and the squares represent a girl's foot. So we can see just two different pieces of data there. And each of the marks on this graph, each of the points on this graph represents a different person. So for this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different people's feet length and height plotted on our scatter plot. Now, person 1 is a boy, and their feet are 18 centimeters long, and their height is 150 centimeters. This person here, they have a foot length of 26 and a height of 158 centimeters, and it's a girl. So that's how you can look at and read a scatter plot. Now, for this question here, it says, which conclusion can be drawn from this data? Now, for this one, we do see a sort of trend arise here. If I took a line, and it's called a line of best fit, I could kind of make an upward diagonal line that goes through my data to see that trend, with about half of them above and half of them below. I'll just thicken up that line, and you can see that there's somewhat of an upward trend in this. So we call that a positive trend. Up, positive. If it were going the other way, downward, we call that a negative trend. So this one asks us, which conclusion can be drawn from the data? A boy has the longest feet. Let's see if that is true. The longest feet are 28. No, that is actually a girl. We know because they have a square there. A girl has the smallest feet. And if I look here, it's actually 18 centimeters was a circle. That is a boy. Taller students tend to have smaller feet. So if I'm looking at their height, is it going to be lower? No, they seem to have longer feet. So if I look here, shorter students tend to have smaller feet. Shorter students, smaller feet. That is true. So for our answer here, it would be D is correct. Hope that helps you a little bit understand scatter plots. If you have any questions, don't forget you can come online and ask me at any time, but go ahead and give it a shot. You guys are going to be interpreting broken line graphs yourself here, and then a scatter plot to see if it has a trend or not. Good luck with it.